we will learn about free body diagram. Free body diagram. mm, so it is just simple as it sounds. Free. It is free from other elements of the structure. We cut that element and replace the other elements by forces that are influencing on the body and calculate our required body's internal forces. So we call that as a free body diagram, which is also in equilibrium, showing all the forces acting on that body. So it is called free body diagram. Hmm, let's understand it through the example. In a person diving using the diving board. So look at that diving board. The diving board has pin connection at one end, then leaving some distance there is a roller connection which we can use to minimize or maximize the length of the board, and at the end of the board there a person stands. So like the diagram shown in the thumbnail, I have shown the working diagram of the diving board and the free body diagram. Determinate structures. Yes, I said determinate structures. It is also as the word sounds, the meaning is same. Determinate, that means the structure is determinate. That means the reaction forces that are at the supports that we can found out using our available equations of equilibrium. This is very technical, but let's understand it through the mathematical point of view. It is very simple. We have number of unknowns is equal to x, and we have equilibrium equations is also is equal to x. So we can find out these number of unknowns using these equations of equilibrium. If we are able to find out the reaction forces using these number of equilibrium equations, then it is determinate structure. And if the structure is indeterminate, that means there are extra support reactions, extra number of members that are surplus. Then we require some additional equations of equilibrium. So such type of structure is called indeterminate structure. In this video, we will see determinate and indeterminate beams. In the next videos, we will see how to determine if the given structure, truss or frame is determinate or not. So let's start. Engineering Fundamentals from the Appendix B, page number B-7 to B-8 by the manual detailing for steel construction by Yuvandhara Tayale. Content of the video is Introduction, System of Forces, Sign Conventions, Equilibrium Conditions, Reactions, Free Body Diagram, Determinacy and Indeterminacy with some examples. Today we will see about equilibrium conditions. So, about what equilibrium? For that, you need to understand what are the types of supports, what are the forces, what are the loads, moment and couple. I have made videos on these topics. Links for those videos is provided in the description box below. Please watch those videos before for better understanding. Reactions. We have already seen how reactions are developed for each type of support. Please watch that video before for better understanding. Here, for your reference, I have provided a summary of the reactions for each type of support. This is the table showing type of supports, reactions and movements and number of unknowns. This table is taken from the book F.E. Civil Review Manual by Michel R. Lindeburg. So, for simple roller or a frictionless surface, one reaction is there, normal to the surface, and no moment. So, number of unknowns will be only one. For cable in tension or link, reaction will be in line with cable or link, and there will be no moment. So, number of unknowns will be only one. If there is a frictionless guide or collar, then reactions will be normal to the rail and no moment. So number of unknowns will be 1. Fixed support or built-in support. So there will be two reaction components, one acting in horizontal direction and one acting in vertical direction, and one moment. So number of unknowns will be 3. Fixed, frictionless hinge, pin connection or rough surface. Then reaction will be in any direction and no moment. So number of unknowns will be 2. Two components of the reactions. Free body diagram. You have heard this word a lot. So what is a free body diagram? It is a representation of a body in equilibrium, showing all applied forces, moments, and reactions. So, while drawing free body diagram, do not consider internal structure or construction of a body. So, we will understand free body diagram. This figure shows a schematic diagram of a load, that is uniformly distributed load over the full length of the beam. This load could be caused from the weight of the floor or distributed live loads. Since each 1 feet length of beam carries a 100 lb share of the load is labeled as either 100 lb per foot or zero point 0.1 kip per foot, where 1 kip is equal to 1000 lb. The symbol small w is used to denote the uniformly distributed load across the full length of the beam. The resultant W of the distributed load is the load intensity multiplied by the loaded length. So first we have converted this uniformly distributed load into single point load, and the resultant is placed at the center of the loaded length. So resultant is been placed. Now, in the previous video, we have seen the types of supports and the reactions offered by them. So here, support A is a pin support and support B is a roller support. And the reactions offered by them will be like this. Pin support will offer two reaction components, horizontal and vertical, and roller support will offer one reaction component, vertical, here vertical. So this is the free body diagram. So the free body diagram of this simply supported beam with uniformly distributed load will be like this. The UDL converted to single point force placed at the center and reactions offered by the supports. So this is the free body diagram. Determinacy. A statically determinate system can be solved for all unknowns, which are usually reactions supporting the body. We will see examples. So, this is the simply supported beam, which is also the example of determinate systems. How? So, here we saw the reactions offered by pin support will be two reaction components, and reaction offered by roller support will be one reaction component normal to the roller. So here number of unknown reactions are 1, 2 and 3. Then number of equilibrium equations for this type of structure are 3. Summation fx is equal to 0, summation of Fy is equal to 0, and summation of moments acting on this beam is equal to 0. So, degree of static indeterminacy DSI will be R minus 3. That is number of reactions 3 minus number of equilibrium equations 3 is equal to 0. So, we can solve these equations, equilibrium equations, and find out all these reactions. So this is a determinate system. So these are some of the examples of determinate systems. Overhanging beam, cantilever beam. So can you verify these systems are determinate or not? We saw determinacy. Now we will see what is indeterminacy. When the body has more supports than are necessary for equilibrium, the force system is said to be statically indeterminate. Redundant members. Redundant means surplus, extra, like the example in English like merge together. Here these two words means the same. So like that in the structure also there are surplus supports or surplus members which can be removed or reduced without affecting the equilibrium conditions. So these extra supports or extra members which can be removed, these are known as redundant supports and redundant members. Degree of indeterminacy. So the number of redundant members is known as degree of indeterminacy. In the subsequent videos made dedicatedly for truss frames, we will see what is degree of indeterminacy and how to calculate it. So here, a body that is statically indeterminate requires additional equations to supplement equilibrium equations. And these equations are generally deflection equations that depends upon the mechanical properties of the body of the support. For example, when there is internal pin connecting the two members, we get one extra equation at that pin. So we will see in that. in examples. So here we will see indeterminate systems. So this is a beam with multiple supports. F.B.D of the beam will be like this. The pin support will offer two reaction components. Roller support will offer one reaction components. So number of unknown reactions are 4 and equilibrium equations are 3. So 4 minus 3, that is 1, will be the degree of indeterminacy. These are some of the examples of indeterminate systems. Beam with two pin supports, propped cantilever. So can you verify these are indeterminate or not? Thank you so much to you all for being with me throughout this video. I'm grateful for your support. Happy learning! For the content in the video, all the credits are given to the AISC committee who prepared the manual detailing for steel construction, and also to the Michelle R. Lindeburg for the FE Civil Review Manual for Reactions Summary Table. If you find this video useful, then please share. It will help others, and subscribe to get notified about the new videos.